Okay, Precal, today we're going to talk about solving exponential logarithmic equations. So let's get to it. We've seen this example before, but 9 to the x equals 3 to the x minus 1. So what you want to always try to do as an initial first step is to get your bases to match up. So when we see 9, we want to recall that 9 is the same thing as 3 squared raised to the x equals 3 to the x minus 1. Now the next move is just a matter of recalling the power rules of exponents. So this is the same thing as 3 to the 2x equals 3 to the x minus 1. And now we can see, since the bases are the same, the exponents are the same, and we're going to set them equal and solve. So the idea here is to get x by itself, subtract x from both sides, we get x equals 1. Want to emphasize that on these types of problems, you can always, of course, substitute the values back in to check. Now, I made a little mistake here. Just realized I wrote x minus 1 to minus 1, then I changed it to x plus 1. So I'm just going to go here and change all of these to a plus. So keep that in mind. If it was x minus 1, then this would just simply be negative. And when I add it over, so x would equal to negative 1. So that's the only difference. So if the question was 9 to the x equals 3 to the x minus 1, then the answer would be negative 1. You can see that from 9 to the negative 1 equals 3 to the negative 1 minus 1. So this would be 9 to the negative 1 equals 3 to the negative 2. 3 squared is 9, but it's negative, so it's negative 1. So 9 to the negative 1 equals 9 to the negative 1. So how about that? 2 problems for the price of 1. Okay, this is the more interesting scenario. So in these scenarios, what we have going on is there's no way to get 3 to match with 7. Someone mentioned the other day that they're both prime. So if they're both prime, then they're not matching up. So what do? So what we want to do is we want to get rid of any time that you have a variable as an exponent, what you can always do is you can take the log of both sides. And we said when the base of the log matches the base of the argument, you're left with the exponent, because that is what a log means. And so we're left with 2x minus 3 equals log base 3 to the 7. And now remember, log base 3 to the 7 is a value. Okay, you can tackle this two different ways. You can last time we learned, you can type it directly into the calculator, or you can realize that it's the same thing as log base 7 over log base 3. So we said log of the small compared to the big is equal to log of the big over log of the small. And remember that this is, when we're looking at this situation, big and small is in relationship to the font size, not to the numbers. However you want to slice it, log base 7 divided by log base 3 is a number. Okay, and I want to stress that because sometimes when people look at this, they think logs, because they're letters, they think variable. But that is not the case. So we're just solving, so we add 3 to both sides, and we get 2x equals log base 7 over log base 3 plus 3. And to finish this off, all we got to do is divide by 2. And this looks crazy, but this is a value. Log base 7 over log base 3 plus 3 over 2. Now by hand, there's nothing more I can do, but if you had a calculator, you would type it into the calculator. All right, let's move on. So the next one is solving an exponential equation. So more of the same. We have 3x over 4 equals 0.8. Again, I want to get rid of I want to drop the variable down. I don't want it to be an exponent anymore, so I'm going to take the log of base 3 of both sides. And so when we do this, because this value and this value match up, we're left with x over 4 equals log base 3 times 0.8. And then we're going to multiply by 4. X equals 4 log base 3 to the 0.8. Okay? And again, you can type it in directly as such. If you rather see this as 4 log 0.8 over log 3, you can write it that way as well. Okay. And number 4, once more of the same. We want to get rid of the e. So we're going to take the log. Now what I'm going to do is I'm going to write this as log base e to the 5 minus 3x equals log base e to the 9 to encourage you to realize that the natural log is the same thing as log base e. So this is the natural log of log base e is the natural log. So we have natural log e to the 5 3x equals natural log 9. Now, when these match up, or when natural log matches up with e, we know that we're just left with the exponent. So 5 minus 3x equals natural log 9. And we proceed to solve. So I apparently really like green. So subtract 5, negative 3x equals natural log 9 minus 5. Divide by negative 3, divide by negative 3. X equals natural log 9 minus 5 over negative 3. And you would type that in the calculator, that would give you the response. Okay? So the big deal here is that when you have a base, you can just do the natural log of both sides, and that will eliminate it. All right, next one. So this is where you have, there's a quadratic, but what I really want you to realize is that we can rewrite e to the x as such. Now, we can play with e to the x here if we want to, but usually what most textbooks like to do is just to say let some letter, I'm going to say y, equal e to the x. And the reason why we want to do that, pun intended, is y squared plus y minus 12 gives us something we're very comfortable at looking at. And we can just simply easily factor this to y plus 4, y minus 3, and then this gives me y equals negative 4, and y equals 3. Now, remember, this is the part that when you're working on this by yourself and you're not familiar with this, you got to make sure that you're always answering the question. A lot of times people just stop here, and a lot of times in multiple choice tests, they will put this as an answer, like negative 4 and 3 as the answer choices. You got to realize that you are not solving for y, but you're solving for you're solving for x, and y is e to the x. So now we'll replace it, and we're going to remember that whenever we see these situations with e, we want to use the natural log. This time I'm just going to go straight to the natural log. And we solve. Now, the other bit that's real important here is the natural log of negative 4 is not a value. Does not exist. You cannot take the natural log of a negative value. The argument of a function is, of the log function cannot be negative or 0. Okay. If you wish to see why that's the case, let me know and I can show it in a subsequent video. For the sake of this one, I'm just going to keep going on. Okay, so x equals natural log 3. All right, let's keep it going. So more of the same. Let's see, blow it up a little bit. Here we're going to rewrite. I'm going to rewrite it as 5 over e to the x, because when it's negative, it means it goes to the denominator. And then my general rule is whenever I see something in the denominator, I try to multiply through to get rid of it. I don't like having things in the denominator. So I'm going to get e to the x times e to the x. Remember, when the bases are the same, you add the exponents, so x plus x is 2x. Minus 5 equals negative 6 e to the x. Now, this is starting to smell a lot like the previous question. I'm going to add e to the 6 to e to the x to the other side. And I'm going to position it. So I'm left with, I'm actually going to write e to the 2x's. Yeah, I'll leave it at that. E to the 2x. No, you know what? No. I'm going to rewrite it as e to the x squared, because we said when we raise something to another power, we multiply, plus 6e to the x minus 5 equals 0. It's debating whether to do it all at once or bit by bit. All right, now what am I going to do? I'm going to say let e to the x equal to a letter. I'm going to use y again. So we get y squared plus 6y minus 5 equals 0. We're going to factor this like normal. So what times what's 5 is going to be, well, here's the interesting part, because y plus 5 and y plus 1 is going to add up to 6. But 5 times 1 is 5. So that's not going to work. So what are we left to do? Well, if we can make one positive, one negative, that's not going to give me this positive 6. So this is interesting, because it seems to be that it's not the case. So when this happens, it's not the end of the world. You know how to solve a question in factoring when it doesn't come out pretty. You can always quadratic formula it. So the quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a. And we know that b is 6, so negative 6 plus or minus 6 squared minus 4 times 1 times negative 5 all over 2 times 1. So we'll get negative 6 plus or minus 36 plus 20 over 2, which is going to get me negative 6 plus or minus square root 56 over 2. Oh no. All right. 1 second. So I ran out of space on the other page, but that's okay. I'm just going to keep working from this page. Keep choosing the same colors. Okay. So 56 is, well, we know 8 times 7 is 56. Right? And I know that 4 times 2, so I'm going to rewrite this as 4 times 2 times 7 over 2. So this breaks down to negative 6 plus or minus 2 root 14 over 2, which gives me negative 3 plus or minus square root 14 if I divide through by 2, which means that I can argue that y is equal to negative 3 plus square root 14, and y is equal to negative 3 minus square root 14. Now y is not just y, it's e to the x. So more of the same. So how do we get rid of the e? We take the natural log. I'm sorry, how do we bring the x down? We take the natural log. Both sides, we have x equals natural log negative 3 plus square root 14. And I'm putting the parentheses to emphasize that. And this was negative 3 minus square root 14, which, by the way, even without a calculator, you should know that that one's going to be incorrect because you're adding two negatives. 9, the square root of 9 is 3. So whatever the square root of 14 is, it's more than 3. So we know that this result right here is going to be positive. So we know that this is going to be the answer. Okay, so not always a pretty answer, not always something super easy to look at, but we can get there. All right, next one. So what can I do here? Well, we can see that they both have e to the x, and they both have an x. So whenever I see that's the case, I'm going to factor out. So I can factor out an e to the x times x. I'm going to be left with 4 minus x squared equals 0. So what can I do from here? Well, we know that either e to the x times x is 0 or 4 minus x squared is 0. So what this tells me, well, x times anything, 0 times anything is 0, so this is x is equal to 0. Over here, this is x is plus or minus 2. And those are your solutions. And you can test it by plugging those numbers back in always, right? So if any doubt, just substitute the numbers back in and you should be golden. Okay, so next up, we're going to do part 2. And in this situation, here's a list of steps towards solving it. I'm not actually a big fan of listing steps. I like to just think organically about what to do. So let's just do that. So if I give you natural log of x equals 10, we know that this means log base e to the x equals 10. And so we called it the claw, but essentially we can write it as a change of position. So e to the 10 is x. Let's go to the next one. So back here, we're doing more of the same. We can claw it. We're going to get 3 squared equals 5 minus x. The goal is to get x by itself. So 9 equals 5 minus x. We'll go ahead and move the 5 to the other side. 4 equals negative x. So negative 4 is x. And I always want to stress, you can always just plug it back in to make sure. And you really should, because if you get a negative inside the argument, you got a problem. All right, next one. So again, more of the same. Now, they have a plus 3, and don't let the plus 3 bug you. Just move the 3 over. Now we have 2 log base 4 to the x equals 4. And you have 2 options. You can take this 2 and you can put it up here. Though I think it's a little bit easier to just divide by 2. You're multiplying. Opposite multiplication is division. So you have log 4 to the x. Log 4x equals 2. Remember, when we see, red's fine. When we see just a log, it means the base is 10, so we can claw it. 10 squared equals 4 to the x. I keep saying 4 to the x, 4x. 10 squared is 100. And you're just doing basic algebra. Divide by 4. 25 is x. We'll confirm. If we plug in 25, we're not getting negatives. We're good. All right, solve a logarithmic equation algebraically and graphically. I'm not really concerned about graphically. Let's do it algebraically. So we know that when we add, addition is the same thing as multiplying. So we can rewrite it as such. Again, we don't want to forget that the base here is 10. So just claw it. 10 equals x plus 1 times x minus 2. And so we'll FOIL it out. X squared minus x minus 2 equals 10. We know anytime we see a trinomial, the goal is to get the trinomial by itself. So we'll just finish by solving. So we'll get x minus 4, x plus 3. We'll solve, so x is 4, x is negative 3. Now this is interesting, we want to double check here. So if I plug in 4, I know I'm good. If I plug in negative 3, I'm going to have some problems here. I can't use negative 3. Big thing is double check your picture, because you can't have negatives in the argument. This is different, yeah. Okay, so here, it's more of the same. You're adding, so it's multiplication. So we have natural log 4x minus 1 times x plus 2. Now with this, I'm going to go ahead and put the 2 on top. So this is natural log x squared. And I hope that it's apparent, because if they're both natural logs, then the arguments have to be equal to each other. So we can just say 4x minus 1 times x plus 2 equals x squared. And we just solve. So distribute. We're going to get 4x squared plus 8x minus x minus 2 is x squared. Go ahead and put the x squareds together. 3x squared plus 7x minus 2 equals 0. And you got two calls here. You can try to factor it, or you can just quadratic formula it. I'm going to try to factor it. 3x and x. Now I know I'm going to get 7, so I need this to be 2 and 1 for it to work, because I'll get 6 and 1. And that will get me 7. but 2 is negative. 2 is positive. Man. Okay. So the deal here. Yep. The deal here is it's not going to work. So you quadratic formula it. Now, I'm not going to really put any of these on the test, so I'm just going to leave it alone. Don't worry about it. And that's it. But you would have to, well, you know what? Let's go ahead. Let's just do it. So quadratic formula, negative b plus or minus square root b squared minus 4ac over 2a. This becomes negative 7 plus or minus square root 49 plus 24 over 6. So negative 7 plus or minus 73 over 6. And 73 does not come out to be anything pretty, so we have plus negative 7 plus square root 73 over 6. And I can't go any further down, so I'm going to squeeze it in here. Negative 7 minus square root 73 over 6. And the bottom one's definitely going to be wrong, because the numerator, both of them are negative, so you're going to get a negative. You can't have a negative inside. Well, you could, but keep doing that. You could. Well, I guess we got to figure it out. Let's think about this for a second. What is the square root of 73? Well, square root of 81 is 9, so it's 8 and some change. So if I plug in 8 and some change, negative times a positive, it's negative, times minus a negative is going to be negative. So yeah, I can't get rid of it. The other one is 8 minus 7 is going to be a positive, so it's going to be an ugly number, but this is a positive value, so this is okay. This is what x is, and there's our answer. So yes, if you get stumped, quadratic formula is an option. For the most part, though, you're going to have situations like this where they work out to be nice. So there you have it, guys. I hope this makes sense. I hope you guys are doing fine with it. Please reach out to me if you're not, and please make sure you're good with this. And I'll see you when I see you. Bye-bye for now.